Okay, so hello everyone and welcome to this session. I hope you are enjoying the event so far. So you can watch this session live on YouTube, so you can send it to your friends and colleagues. You will be able to see it also after the event if you want to. So welcome, I'm gonna quickly present myself. My name is Tristan. I am a Power BI consultant at Azeo, a Microsoft partner in France. I am mostly in charge of developing Power BI activities, such as consulting services, trainings, and so on. I set up the Paris Power BI user group back in February 2017. So we basically organize monthly meetups in Paris about any topics related to Power BI, such as Power Query, data visualization, DAX, but also Power Apps Flow. It's quite exciting to see this community growing so fast. We have nearly 450 members already. And yeah, if you come to Paris, just feel free to join us, either for attending or speaking at this event. Well, obviously, it's better if you can speak or at least understand French, because you know how bad French people are in English. And yeah, most of our sessions and events are in French. Also, feel free to follow me on Twitter and LinkedIn. I'm quite active on these social networks, and I share a lot of things around Power BI, data visualization, and all the Power BI news that you want to have. Okay, so the session of today is about how to cope with many-to-many in DAX. So pretty technical. We'll not deal with data visualizations and dashboards and so on. We will clearly focus on the modeling capabilities and the DAX language in Power BI. I will try to show you how we can solve this issue. I'm sure you have heard and you have all experienced at least once in your Power BI life. You have all seen this message saying that you cannot create a relationship between the two tables. So this is the issue we are going to address today through a very concrete use case. I didn't want to do too much theory about many-to-many. I really wanted to show you how you can tackle this issue with a concrete example. So here is the agenda of today. We'll see some tabular modeling best practices on how you should model your data in Power BI. This will be very useful for the rest of the session. Then, as I said, a use case. Basically, it will be a training company, and we will see how we can cope with many-to-many. And then a few comparisons. We'll see different methods in using the DAX language to tackle the issue. We'll compare this method and then try to conclude and take a step backward. Okay, so a few recaps and a few things that we should all be aware of when we are doing some modeling and preparing data in Power BI. The optimized schema, as you may know, is a star schema with denormalized dimensions surrounding your fact tables or your single fact table. This is how you should model your data in Power BI, and this is how the storage engine called Vertipack or X-Velocity is optimized for, because it stores the data not row by row, but column by column. We talk about in-memory columnar storage. So basically, this means that your dimensions do not need to be normalized. You do not need to split each of your dimensions and create some snowflakes and so on. But this star schema makes it really easy for your business users to analyze the data and your storage to be optimized. The second point is, as you saw, some relationships between the tables. You have some dimensions and facts, so you need to link them. A few things that you should be aware of. The first one is to create a relationship between two tables. Obviously, you need to have a common key, a common column, which will make the link between the tables. And the second condition is the uniqueness from at least one side of the relationship. Natively, Power BI does not support many-to-many relationships. You always need to have at least one side of the relationship, so one of these common key, which has unique values, okay? And that's the problem of today. In real life, that doesn't happen so frequently, and we have to deal with these kind of problems. Another thing is the direction of these relationships. It always goes from the one side to the many side, so from the dimensions to the facts. The opposite is false. Natively, Power BI and Power Pivot does not support relationships which go from many to one. It always goes from the dimensions to the fact. So these are the things that we should be aware of before tackling the many to many. And we will use, from now, I will assume that we know these things and we will use them in our demo. So I will just quickly present you the use case of today. So basically, I imagined just one thing I forgot to mention. The data, the volume of the data we're gonna manipulate is very low. Okay, we're not gonna manipulate a huge data set because the idea is that you can catch the concepts of modeling. Obviously, you could apply what you're gonna see here to bigger databases. So in this case, pretty simple. I have a training company. So this is the main table of my model. Again, not pretty large, only 120 rows, where I have sales by date for a particular training and a particular country. Okay, so these are sales. Let's assume it's in Europe. Okay, the second table is basically our main dimension table, and it makes the link between the training ID, which is here, the name of the training, the ID of the trainer, and the name of the trainer. And you start to see what kind of problems we're gonna have here in our use case, because the same training, let's say training 1, is delivered by several different trainers at the same time, because we're gonna assume there are many trainers in the room. And on the other side, a given trainer, let's say Sarah, delivers different trainings. Okay, so you start to see the kind of problems we're going to have here. It's clearly a many-to-many situations, and none of these fields is unique. So we already know that we're going to have some troubles when we're going to try to link this table to our main table that I've just shown you. I have another couple of tables here. The budget table, which is the forecasts of my sales per date per country. In this database, I don't have the information per training. Another small table which makes the link between my countries, their name and their continent, and a classic calendar table, which basically provides some useful information about year and month. Okay, so this is the starting point. I have imported the data in Power BI Desktop. So this is basically all the tables that you have just seen. And you can see the relational model for now, which is obviously empty. We're going to create the relationships and try to model our data. So this is the starting point. Actually, from what I've just told you about these best practices, dimensions, and facts, we're going to tackle the many-to-many issues through two angles. The first case we're going to see is many-to-many relationship between two fact tables. And there is another case that we're going to cover today as well, is the many-to-many case between a dimension and a fact table, which is a little bit more complicated. So let's start by the first one, many-to-many situation between two fact tables. So in this case, I have two fact tables, which are the sales table and the budget table, okay? So remember our conditions for creating relationships. The first one was a common key, which they have. In fact, they have both dates and country, okay? But the other condition is missing. In each of these tables, all these fields do not have unique values. So if I try to create a link between these two tables, because I want to be able as an analyst to get insights from data and to compare over time or by country my sales, I cannot link them directly, right? I'm going to end up with the message I've just shown you. We are missing the uniqueness of values. So how can you tackle this kind of issue? Well, it's indeed pretty simple. So we have two fact tables. We cannot link them. Okay, I've just shown you. So the solution is finding at least one common dimension with identical grain. Okay, so in our case, we are lucky because we have two dimensions, which are calendar and geography. And I can use these tables because they are kind of lookup tables. They are reference tables, which make my keys unique. So here is the date, which is unique, and for the geographic table, this is the country, which is unique. And then I can leverage these tables to link my two fact tables, which are sales and budget. So pretty obvious, right? I'm gonna do it here on Power BI. So I will just reproduce the content of the slide. I'm gonna quickly create the relationship between my calendar table and my sales table. Okay, and then I will create the relationship between my geographic table and my sales table. Okay, right. So here is my first modeling. Now I'm going to be able to actually analyze my sales versus budget over time and geography. So you might be a little bit confused because, yeah, I have several relationships. There is one thing I didn't mention in the best practice and in the way Power Pivot works. You can only create one relationship, one active relationship between two tables, okay? But a given table can be linked to several tables, right? So for example, the calendar table here, okay, has an active link with the sales table and with the budget table. It doesn't matter, right? Yeah. Ah, okay. Okay, thanks. Date and ID country. Oh, it looks okay. Oh, yeah, you're right. Sorry. So this will allow me to show you how you can manage your relationships. We're going to say, okay, so this one, I'm going to edit it. You're right. And I'm going to create the link between the relevant and the correct one. And this one as well, I'm going to edit it and create it with the key. Thank you very much. So this is now correct. So I will go back to the report view. And now as an analyst, I'm going to be able to leverage my analysis and my modeling. Here I have created two measures. It's a best practice in Power BI to reproduce some measures which are calculated implicitly by the model. It's a best practice to reproduce them using the DAX language here. So I have my two measures, which are total sales and sales versus budget. And because I took the time to model my data and get rid of this kind of many-to-many issue, I can now leverage it. And for example, let's see by country, the sales versus budget. Okay, so I'm not going to use the country ID, but probably the country name. And I can also leverage the additional information I have about the continent and use some drill downs, leverage the other common key I had, which was the calendar table, and probably see my sales versus budget over time and over by different countries. Okay, so this one was actually pretty simple. It was kind of a smooth introduction to many-to-many. We will see another case, which is more problematic. It's when you have a many-to-many situation between a fact and a dimension table. So in this case here, so I'm just gonna clean this a little bit. We're not gonna use these tables anymore, so I'm just gonna leave them here. Okay. So here is my data model. So this is my main fact table again, and this is clearly a dimension table, the trainings. But as we saw, none of these fields here, are unique. So for example, if I try to create a relationship between my training ID and my training ID here, I won't be able to do it for the same reason as before, obviously. So what we need to do is to reshape our data and to make sure we can still see and analyze the measures that we have here through these dimensions. And actually, I would like to be able to see my sales by trainer and by training, for example, okay? So to do so, we're gonna use something really interesting, which is for me one of the key differentiator of Power BI Desktop compared to other tools. It's called Power Query, the query editor. Maybe you have attended some sessions about it, and I'm sure you're using it every day as a Power BI user. it clearly is a differentiator because it helps business users reshape their data, clean it, without really having to know how to code. And I think this is really useful, especially in a self-service BI context. So here I will simply edit my query. This will open the famous query editor. And we're going to do a little bit of mashup so we can prepare our tables and actually make the relationships between the tables. So just go back to the slides. So this one, we saw it. Okay, between two fact tables. Now, between the fact and the dimension. So as we saw, we cannot link directly the sales and the training tables. So we need to find something else. Actually, the method consists of creating a bridge table, which basically will make the link between your trainings and your trainers. And then we will create two separate tables. The first one will be the trainer table, which will have the trainer ID, which will be unique, and the training table, which will make the training ID unique as well, plus some information about the name of the training and also the number of trainers per training. And after doing that, we will then be able to create the relationships like this and like this, because my trainer table will have unique values. So I will be able to link it to my bridge through a one-to-many relationship. I will be able to do the same between my trainings and my bridge table. And then I will be able to finally link my trainings table to my sales table. Okay, notice that you cannot see my stuff here. So let's begin. I'm gonna use Power Query to do that. So here I have my trainings table, which I'm gonna duplicate. Oh, why don't you see this? Let me check. Probably it's because of... Okay, great. So here is my training ID, my training table, sorry, I just duplicated it. And we're gonna create our trainer table. So basically this one, I'm just gonna get rid of the useless columns. So I just remove the other columns. Oops, sorry, this was the other. This one, and I'm gonna remove them. So this is kind of my bridge table. It makes the link between my trainer ID and my training ID. So I'm just gonna rename this bridge. Then this table will be my trainer table. And what I will do is I will just keep the ID and the name and get rid of the other columns. And I will leverage this functionality, which is called remove duplicates, and which allows me to remove duplicates on a particular column or on the columns which are currently in my database. So here I'm just gonna click on this column and remove the duplicates. So here I have a separate table, which is my proper trainer table, and it has actually my trainer ID as unique, and it associates to him his name. Okay, now we're gonna create the training table. So kind of the same stuff. I'm just gonna this one. Actually, I should have copied it before. Just remove this. I'm gonna quickly show you another technique to have some duplicates in Power Query. You can also either leverage the remove duplicates feature, and you can also perform some group by. So that's what I will do here using this button called group by. So I'm gonna say, okay, this table, which I'm gonna call trainings. I'm gonna group by the data. So in this case, I'm gonna use the advanced feature and say, okay, I wanna group this table by training ID and also by training name. And then I'm gonna perform another, I'm gonna have one additional information about the number of trainers there are per training. I think you will agree here that if I count the number of rows, sorry, I have in this database, this will give me the number of trainer I have per trainings, right? So I'm just gonna say group this current database by training ID and by training name, and also count the number of rows I have in the results. So this will basically give me the number of trainers. Okay. So with this transformation, I do two things at the same time. Not only I get the training ID, I will make them unique, but at the same time, I have something interesting that we will leverage after, that is the number of trainers per training. Okay, so now we have these tables. Best practice would be to group these query, probably in fact and dimension tables, so we can see clearer what is the role of the different tables and so on. I'm not going to do it here, but just for best practice suggestion. So here again, this one. So as we said, we're going to create the relationships for now using the data model, because now we have brand new tables in our data model. Oh, I forgot to close and apply. So this will basically load these new tables in my model. And again, I'm going to reproduce what I've just shown you in the slides. So here, I'm just going to put my bridge table here, my trainer and my trainings table. So I'm going to link, oh, sorry, I did it wrong again, with the trainer, training ID, no, sorry, trainer ID. And then I'm going to be able to link the training ID here. So this works basically because, as I said, these tables make each of the fields that are used in the relationship unique, right? And then I will finally be able to link my trainings table to my sales table, which is obviously the goal, because I want to see all my metrics through these dimensions. So for the moment, they are not linked to my main table. So I will just link the training ID here to my sales table. Okay, right. So now we have our data model, which is prepared for many-to-many. I could get rid of the issue by creating a bridge and leveraging different relationships. So now, remember the goal of the session. We want to see the total sales, or why not the sales versus budget, let's say per trainer. So now I have this model. I'm just going to go back to the report view. And I will try to see by trainer. So let's say by trainer name, I'm just going to create quick metrics, which I will, where is it again? The grid, text size, by total sales. Okay. And this obviously doesn't work. Power BI is not able to split the total sales by trainer, even though we could get rid of the many-to-many issue and create the relationships. And obviously, I have the same result for each of my trainers, which corresponds to the total of my sales for all my trainers. So why? Well, this has to do with what we have seen in the introduction, is the flow of the relationships. If you remember well, we saw that natively in Power BI, the relationships only flow from the one side to the many side. So let's go back to the data model and try to understand what is happening here. So I'm slicing my data with this table. I want to see the data per trainer. So the relationship goes down, it reaches the rich table, but then because on this side I'm on the many sides of the relationship, Power BI is not able to make the relationship flow uphill, reach the trainings table, and then reach the sales table, right? So actually, it stops here. It simply stops here. It doesn't transmit the information to the trainings table, and that's why it makes as if there were no relationship between the table, and it displays the total sales per trainer. So I need to find a way to make this relationship flow uphill. And to do so, I'm going to leverage the DAX language, which I'm sure is one of your best friends in Power BI, because DAX is very powerful if you want to interact with your data model. So we're going to see 4 different methods to address this issue. Some of you must have attended the Casper session this morning, which has shown some DAX functions to cope with bidirectional relationships and so on. So I will cover this as well, plus other methods which are a bit advanced in DAX. So go back to the slides. So we saw this. Okay. The different models that we need to do. And then, as I said, second step is to use the DAX to make it work. So 4 methods. The first one will be the bidirectional filtering. So basically, you can apply bidirectional filters for relationships in Power BI Desktop and SSIS 2016 and 17 now. So it's basically at the data model level. So this will be available for your whole data model, and this will apply for the given relationship that you're creating. It's quite simple. We're going to see in a sec how to do this in Power BI, but it's expensive because it's not optimized for the VertiSpec engine. And also it can generate some ambiguous models, because think about it. If you apply some bidirectional filtering, it means that your fact tables will be able to filter your dimension tables. So through this capability, you're going to create several paths for given relationships. This will create some ambiguous models, and this will obviously make things a bit weird when you're trying to compute some measures. So some DAX and SSIS gurus like Marco Russo or Alberto Ferrari, like the SQL BI guys, generally they suggest that this method that we're going to see is acceptable in a single fact table model. When there is only one fact table in your model, this bidirectional filtering is acceptable. So let's see how we can do it here. I'm going to go back to my model. And as we saw, we need to flow this relationship uphill. So I'm just going to double click on the relationship. Again, I don't know why it's doing this, because usually it should. Okay. So we're going to make this flow uphill. So I'm just going to double click on the relationship. And here you have a menu which tells you, okay, what is the current cross-filter direction? The native way to do it in Power BI is single. So this means, as we said, that it naturally flows from the one side to the many side. Just a comment around this. I think before February 2017, so yeah, a few months ago, the native kind of relationship between 2 tables were bidirectional. And some MVPs asked Microsoft not to do this kind of thing, because I think Microsoft wanted to democratize the way business users can cope with many-to-many, and they wanted to make the cross-filter direction to both natively. But as I said, because it was generating some ambiguous models and it had some troubles about the performance, they set up the single direction as a native feature. So you can apply it to both, and this will basically, so this will basically, as you can see here, turn it to bidirectional filter, and this will mean that your bridge will be able to reach the trainings table and then flow down to the sales table. So if we go back to the report view, now it's working. Power BI is able to split the data per trainer. So this method has some drawbacks. So that's why I'm going to show you another method, which is the same one, but at the measure level. And to do so, you can leverage the DAX language, and you can apply this kind of bidirectional filtering, not at the data model level, because this that we have just done before will clearly impact the whole model. It's available for the whole model. This pattern, you can leverage the DAX to create this bidirectional filtering locally on a measure. This pattern is available on the same technologies as the first one, plus a Power Pivot in Excel 2016. Yeah, so I forgot to mention that if you are using Power Pivot for Excel, you cannot leverage the first method that we have just seen. The bidirectional filtering is not working, is not available in Power Pivot for Excel, mainly due to compatibility issues. But in Excel 2016, through Power Pivot, you can apply this feature locally on a measure. So that's what we are going to do here. I will go back to the model. So I will turn this off. I will get it back to single because I don't want it to have an impact on my whole model. And I'm going to create another measure, which I'm going to call, let's say, we're going to name it with the name of the method, so cross filter. So this is the pattern that we have to apply. Calculate. I'm just going to reference my measure, total sales, in another context. So I'm using the calculate function. This session is not about DAX. I'm not going to explain to you everything about DAX, context, and so on. I just saw that you had a session about this just before. But basically, what you have to know is that calculate allows a power user, a user who creates relationships, to evaluate a measure in another context. And this other context here will leverage the cross filter function, which basically turn the relationship between your bridge and your dimension to both, to bidirectional. So the pattern here is to apply on the first argument, the left column name, we're gonna apply the one which is on the many side. So this will be my bridge table, and I have to put the relevant column. I need to flow uphill for the relationship. So this is my training ID. I will go for the same here, training, and this will be my training ID here. And this last argument tells me, okay, what kind of relationship you want to have between these two keys locally, just for this measure. So I can turn it to known, so I can basically turn off the relationship. I can turn it to one way, which is the default behavior, and I can turn it to both ways. So now I'm going to use this brand new measure. And again, it's working. I'm just going to make sure it's nicely formatted. And it's displaying the correct results, which is, by the way, of course, the total sales per trainer. So these are two methods leveraging the bidirectional filtering. We're going to see two other ones, which are a little bit more advanced. Yeah.
What you comment to the total is equal in the second cross-filter column, the total?
Yes, it's
equal to the second one.
Yes, it's because in this particular example, Josh, which one are you talking about? Are you talking about the particular train?
The second column.
Yes.
Is in total sum. In the last row, 231.
Yeah, it's because it is not an additive measure. I mean, I have some trainers who have done all the training, so yeah, they are equal to the total. Yeah, this is not an additive measure, this one. So the third method is purely based on context. And basically, we're gonna use the power of the calculate function to switch from a row context to a filter context. So I don't know if you are easy with this concept. I'm not gonna go deeply in this session, but what you have to know is that there are two contexts in DAX: row context, which is basically when you're creating some calculated columns, and filter context. So the context that comes from the choice of the user through the slicers, page filters, and so on, and also the graphs, which are a source of filter in Power BI. You can play with these concepts using Power BI and DAX, and you can use this feature to cope with many-to-many issues. So this is the pattern. You can, again, use the calculate function to reference the measure in another context. And these other contexts will be this part, the filter part, when you are basically filtering the column with the table, which is on the left side of the relationship, and you are trying to see if there are some occurrences in your bridge. So rather than explaining in detail this pattern, I'm just gonna do it in Power BI, and then we will see a small schema which explains the method. So I'm gonna create a new measure, which I'm gonna call context transition. So again, I'm using the calculate function, total sales, which I'm gonna evaluate in another context. And this context will be a filter of the table which is on the left side of the bridge. So the training table, training. Okay. And then I'm gonna filter this table and check if for each of these, for each of the row of this table, if there is an occurrence, if there is something happening in the bridge table. So to do so, I'm just gonna check count rows in my bridge table. Is this superior to 0? So this basically means for each of the rows which are currently in the trainings table, is there something in the bridge table? And this will basically virtually make the relationship flow uphill. Because remember, the problem was between our bridge table and our trainings table. So this is the pattern that you can apply. This is not gonna work now. I'm just gonna show you what is happening. I'm just gonna bring in the measure here. And again, this is not able to split between the trainers. The reason why is because for the moment, I haven't applied the context transition. If I want to make sure here that for each of the row of my trainings, I want to see if there is something on the bridge, I need to transform the row context that I have created through this function to a filter context. And to do so, I just need to embed this expression with a calculate. So I will just say calculate, count rows in the bridge. And this one works. So as you see, I have the same, I can just get rid of the total sales measure. And obviously, I have the same result as the method we have just done before, which is the cross filter. So basically, what this method is doing is we are checking. So this is the training table. I'm iterating over it using the filter function. And I have a filter expression, which is, please, can you check if there is something in the bridge? To do so, I need to embed it in a calculate. Internally, it generates a Boolean for each of the row of the table I'm iterating over. So which is the first parameter of my filter table. And it says true, false, true, for example. It's going to retain only the rows which are true, obviously. And it's going to apply this virtual filter table to my main table. So this is what is happening behind the scene. And because I want this pattern to apply for each of the rows of my trainings table, I have to leverage the context transition using a calculate. I'm gonna quickly show you how you can simplify this expression to show you a little bit of DAX in action. So actually, a best practice would be to create a separate measure, which will have this expression, count rows of bridge. So I'm just gonna say in the bridge table, I'm just gonna say count bridge. I will just count the number of rows I have in my bridge table. And then in my main measure, I'm just gonna replace this expression by the expression of the measure. And it's gonna work directly. I won't need to embed it into another calculate, because when you are referencing a measure in another measure, it automatically assumes that there is a calculate. So it's gonna basically apply the context transition and switch the row context to a filter context. So I'm just gonna switch this expression to this one. I'm just gonna say count if there is anything in the bridge. And obviously it's working. I can show you another, let's say, tips and tricks. The fact that you can leverage variables in DAX. So this is a really powerful feature. It allows you to create local variables in your measure. And what is interesting with these variables is that they make your code easier to read, easier to clean and to maintain. And they can store either scalar values, which are the result of a given expression, or they can store, the variables can store tables. So this is really useful if you want to make your code a bit clean. I'm just gonna create a variable. So this is the syntax bar. So I'm just gonna say, I'm gonna call it filter table. And this table will be the result of this one. Okay, so return. So this is the pattern. I am basically creating a variable with a var text here. And the expression of this variable that I called filter table is basically the result of the schema I've just shown you. We are iterating over each row of the training table and counting if there is an occurrence in the bridge table. So I'm just storing the result of this table in a separate variable, which is local. This variable is very important to know, is local to the measure. It won't be available anywhere else for the moment. You can support the idea to have global variables in Power BI. I voted for it on powerbi.this.com. This would be a major advantage to have the possibility to create variables which are available to any of the measures of your model. This is not available for the moment. But still, for this case, it's very useful because now rather than having this weird stuff, I just can say that my other filter context will be my variable. So as you can see, it doesn't have any impact on the performance here. It doesn't have a major impact on how you understand the feature, but at least it's a little bit clearer to understand and a little bit cleaner. And obviously, it works. Okay, so this was the method on context transition. We still have 15 minutes left. I have a last method to show you. So this one is probably the easiest one in terms of syntax, but conceptually, it's the hardest one to understand. So this is basically called the bridge method. And actually, it's the wrong name. It's the expanded table method, but anyway. So is basically a method which is based on the concept of expanded tables. So I don't know if you have heard about this concept in DAX, but basically what it means is that when you are referencing a table in a DAX measure, you are also referring to all the columns of its dimensions. So basically here in this pattern, so again, I'm not sure you're gonna see it here. No, you won't see it here. But when I reference my bridge table here in my measure, it will basically, the underlying engine will also reference all the dimensions which are linked to this bridge table. And basically, in our case, our bridge table was linked to the trainer and the training tables. And this will have an impact on the many-to-many because when I reference, maybe we can do it before in Power BI, and then I will show you with the schema. So I'm just gonna say the screen again because of the presenter mode, but normally it's able to make the switch alone. So I'm just gonna say create a new measure, which I'm gonna call expanded tables. I'm gonna say calculate, again, our best friend, total sales. And then rather than doing some complicated stuff, I'm just gonna say bridge. So this will be my expression. You can OK, and then use it in my matrix, and it's working again. So what is happening behind the scene? Well, actually, as I said, when you are referencing a table, it inherits the columns for dimensions. So in this case, when I reference this is my bridge table here. I have the mapping between the training's ID and the trainer's ID. Actually, underline, it's also storing the columns coming from the training table and the columns coming from the trainer table. So when I apply a filter, let's say on Sarah, so I have Sarah on my matrix. Internally, the engine is gonna expand the filter and return the relevant result. So that is to say, the number of sales or the total sales for Sarah, even though I didn't create the correct relationships and so on. I don't need to turn these relationships to bidirectional. They just need to be there. Oops, sorry. And basically, Power BI will just make sure the table which is referenced stores the dimensions which are linked to it, and it will literally expand the filter. So this is what is happening behind the scene, and this is why this pretty simple method is working. But actually, I didn't want to show you this at first, because to end up with this kind of results, you need to understand how the DAX engine is working, how you can manipulate the context, and so on. So we saw the different methods. Now the idea is to compare them and to try to take a step backward and understand what is happening. So I just summarized here the method that we have seen. So we saw 4 different methods. The fact that you can leverage bidirectional filtering at the model level, the cross filter that you can leverage using DAX function. We saw the context transition method and the bridge. So I decided to compare these methods through 3 angles. The first one is the syntax complexity, the DAX syntax. The second one is the availability. And the third one is the performance. So if we take a look at the syntax complexity, well, the bidirectional, I put simple, but actually it's none. We don't have to write any DAX, right? We just need to turn on the bidirectional filtering. The cross-filter is measure. You just need to use the cross-filter function in your calculate and put the correct parameters. The context transition is a little bit more complex because we need to switch from row context to filter context. We need to understand how these contexts play together. And this bridge, as we saw, the syntax is pretty easy, but it's kind of a smoke screen because you need to understand everything before applying it. The second angle is the availability. So the first 2 methods are available only in particular technologies, Power BI Desktop and SSIS 2016 for the first one, Excel and 2016 for the second one in addition. And then the 2 other methods, you can leverage them in any of the tools. Power Pivot for Excel 2010, 2013, Power BI Desktop, SSS 2016. There is no problem for that. Then the performance angle. So this one is important when you have large models and you want to be able to cope with many issues with, I don't know, millions of rows and so on. So basically, I hadn't scheduled to show you this, but maybe since we have a little bit of time, unless there are questions, I will quickly show you how I ended up with this kind of table. For the performance angle of analysis, I used DAX Studio. I don't know if you have heard about it. So this is sorry?
DAX one.
DAX Studio.
No, DAX Studio.
Yeah, I'm just gonna quickly show you after how it works. So DAX Studio allows you to make some tests on your model. So basically, you can connect to SSS models or Power BI desktop models through the DAX Studio, which is a tool which has been created by Marco Russo, Alberto Ferrari, and some other guys. And this will basically allow you to understand how the engine is working, what is running behind. You will be able to see how responsive are your measures, and you will be able to materialize your tables through filters and apply some DAX expressions to see the results of some tables and so on. And I will quickly show you how it works. I used this tool against a big data model, okay, which had many more rows, much rows than we saw earlier. And I ended up with this conclusion: the global bidirectional filter has a bad impact on the performance. It clearly reduces the impact of the performance. The cross filter is pretty performant. It returns, I mean, the measures are able to compute very quickly. The context transition method, it's a medium performance. It's not that good, but it's not that bad. And the bridge table is good, and it's actually probably higher than the cross filter method. So basically, if we summarize, the best method seems to be the bridge because it's available everywhere. The syntax is simple and the performance is really good. But if you need to explain this to your business users, probably you will need to invest some time on filter context, row context, filter expansions, data modeling, and so on. Okay, so the last thing before maybe I can show you DAX Studio is kind of a bonus. I want to be able to make a prorata of each trainer's turnover. Because what we have seen so far is, if I go back to my model, I will just expand this. This is, so let's say we're going to keep only the cross filter results. So this is basically the total sales per trainer, but not exactly. Because this is actually the total sales per trainer who participated to a certain training. So let's say that I put the trainings here. I'm going to put the training name, and we go to this one. No, sorry, I'm going to use this one. So yeah, this one. Yeah. So as you can see, the DAX basics, which was one of my trainings, I ended up with these total sales. And for the moment, with the measures we have created, we are able to split the total sales per trainer, thanks to the different methods that we have just seen. But I want to go further. I want to know the contribution of each of my trainers. Because remember, we had assumed that different trainers were delivering the same training at the same time. So for example, me, I could have a colleague here who is delivering the same training. He's together with me. We are trying to explain to you how to cope with many DAX. And I want to know at the end of the year, what is the contribution of each of these trainers to the general turnover. So to do so, I need to be able to divide my total sales by the number of trainings my trainer has delivered. And if you remember well, when I showed you the group by feature in Power Query, we could extract another information, which was about the number of trainers here, I could extract a very useful information, which is the number of trainers per training. And thus, with this feature, with this additional column, I will be able to compute the exact proportion, the exact total sales per trainer, because I want to divide it. So to do so, I found a method which might not be the best. If you're really a DAX guru, I would be more than happy to see how you would tackle this issue. I've created a double summix because I need to recreate a filter context for the trainers and for the trainings. So this will be the measure. I will put total sales real. So this will be a summix over my trainings table, plus another summix on my trainers table, for which I will evaluate the total sales. And I will, this one, divided by the number of trainers. So this is my DAX expression. And basically what I'm doing is that no matter what is the context, I want to see the actual contribution to each of my trainers to the total sales. I will put it here, and thus I will be able to see by trainer my total sales. And here you can see that compared to this feature, total sales, Power BI through this measure is able to make the split and clearly identify what is the proportion of each of my trainers. Yeah, so this is the expression. I will share, so this video has been recorded. I will share with you the data model if you want to play with it and see how you can apply the different patterns that we have seen using DAX. I think we still have a few minutes left. I can either answer some questions or just quickly show you the DAX Studio interface. It's as you prefer. Yeah, any question? Yeah.
Does it matter what dimension you link first to the DAX point-wise? You see the dimensions on the bridge?
Yes.
You link one of them to your DAX. Does it matter which one for performance?
Well, actually, this is a good question, but in this particular case, I had no choice. Because in my fact table, I don't have the trainer ID. I only have the training ID. So this is why I modeled it this way, the trainer, the bridge, and the training. But in any case, this would not have an impact, I guess. But I could have the trainer ID here on my sales table with a join, left outer join in Power Query, but this is totally useless. We saw in the best practice that we have to keep the dimensions and fact table separate and use a proper star schema. Other questions? Okay, do you want me to show you quickly DAX Studio, maybe?
Yes.
Okay, so I think, yeah, I have it here. So you can basically download this for free, DAX Studio. So this is a tool which has been developed by the SQL BI guys, and they will explain it better than me. It's a tool to write, execute, analyze DAX query in Power BI. We forgot to update it. Desktop. It used to be the old name, Designer. Power Pivot for Excel, Analysis Services Tabular. So when you want to test some queries and see the performance of your measures, it's a perfect tool for that. So here, I've connected to it. So what you need to be aware of is that when you have a Power BI desktop model which is open, it creates a SSIS instance which is underlying and which you can connect to. So this is exactly what is doing DAX Studio here. You can connect to a PBI model, which will be this one, thanks to the underlying SSIS instance. So this will create a live connection between DAX Studio and my model. And for example, I will be able to make some tests. So let's say, for example, I will run evaluate. I will just say calculate table. So we're gonna say trainer, and then total sales. So normally you can refer to the let's say cross filter superior to 40, let's say 100,000. You can run this query. Well, I will have to check it out. Well,
Filter function.
yeah, but no, usually this should work. Yeah. Let's say, oh yeah, okay. No, but usually this should work. Oh no, maybe I have to put trainer, and then maybe filter, trainer. Yeah, I haven't been using this for a while. Cross filter, superior to 1000. From this should work. Yeah. So yeah, in this case, there isn't the trainer D, which must have total sales inferior to the query. So as you can see, this is pretty a good way to what we call materialize your tables, especially when you can use these tables as a filter in other measures. But in Power BI, this is called a virtual filter because you don't actually see the table that is applying the filter to your calculate. Using these tools, you can easily manipulate your data and see what will be the result of your queries. And the other thing is about the performance. So here, I think that if you remember well, you can return the timer. So here you will see the duration in seconds in milliseconds of each of your queries, and you can either go deeper and, for example, let's say turn on the query plan, run again this query. So I'm just gonna, yeah. If I go to the query plan, I will be able to see what is the underlying code. Normally, I should be able to see also, let me run it again. Yeah, the allocation between the formula engine and the storage engine. So this is basically the two engines which are at stake when you are using a DAX measure or DAX filter, DAX to retrieve the table, for example. So this tool is pretty useful, and I used it against this data model to try to identify what were the methods which were the best in terms of performance. So yeah, this is it. As I said, feel free to add me on Twitter. You will be providing the link of this session if you want to see it again or share it to your colleagues. And thank you very much. I really hope you enjoyed the session.